Okay, we will start without wasting the time. Okay. So what we discussed in the previous class, so we have discussed different parameters, the environmental conditions which are affecting the what we call the corrosion rate. Fine. And in today's class, let us discuss two important derivations. The derivation which leading to an equation called Nernst equation. So what is Nernst equation and how we will arrive in deriving the Nernst equation. Before going to the derivation of the Nernst equation, let us understand a few basic concepts because the basic concepts will give clear idea of usage of Nernst equation. Now my question is, for example, the same reaction if you take 2H plus 2 electrons gives us H2. So here there are the stoichiometric coefficient of H plus is 2. The stoichiometric coefficient of electrons is 2, and the formation of hydrogen, the stoichiometric coefficient is 1. Now, if you remember, maybe in 10 plus 2 stage, the Faraday's law, the basic Faraday's first law, what it tells is when any n moles of substance reacts, then it is proportional to the amount of the charge that is transferred across electrode electrolyte interface. So what is Faraday's law says? If you go back maybe in 10 plus 2, the Faraday's first law says if Ni moles of substance reacts, the amount that is reacting is proportional to the amount of charge that is passed across the electrode electrolyte interface. So here in this case, for example, there are 2 moles of H plus ions are reacting in the reaction. Subsequently, what is the amount of charge that is transporting across the electrode electrolyte interface? 2 electrons. Is it not? 2H plus 2 electrons I am saying. So if Ni moles is reacting, subsequent charge will be transferred across the electrode electrolyte interface. So this is the electrons that is transported. So how much amount of substance is reacting, that is the how many moles reacting, equaling proportional amount of electrons will be liberated out or transported across the electrode electrode interface. That is the Faraday's first law. If you remember, go back, that Q is equal to N into F. We will write. Maybe I can show you the equation. Yeah. Q is equal to N into F. Where what is F called? Faraday's constant. So around 96,485 coulombs per mole. Fine. So why I am bringing this concept of this Faraday's first law is because now the Nernst equation which are going to derive consists the terms of electrical energy, Gibbs free energy, and then the number of moles or the stoichiometric constants, proportionality limits. They are all involved in that reaction. For that, we should understand basically what are these individual parameters. Now, can you remember in thermodynamics, we more often talk about the Gibbs free energy G. So, what is Gibbs free energy? What is Gibbs free energy? Because see, these are all basic questions. If you go to any interview, they will ask only the basic questions. They never ask for the derivations until unless organizations called BARC or NALCO, NALCO, these bigger organizations, Navratna company only, they will ask for the derivations or some problems they will ask. For smaller companies, they will ask only the basic question. No, Gibbs free energy, chemical potential, those very small questions, fundamental questions we should answer. Okay, so let me give an example here so that you will come across the definition of Gibbs free energy. Look at this example. For your sake, I am giving with an example so that you will better understand what is Gibbs free energy. Okay, because it's a very simple concept in thermodynamics. I don't know whether how much you content you learn from the thermodynamics, but let us see this example so that you will come to know. You will remember for a long time what is Gibbs free energy. See, I have given here one example. See, I took a cylinder. I took a cylinder where hydrogen gas is there, which is at a pressure of 10 atmospheres. Okay, and this valve is closed. so that the 10 atmospheres hydrogen is inside the tank, inside the cylinder. Now, what is the outside atmosphere pressure is 1 atmosphere, because outside is 1 atmosphere, but gas which is holded in the cylinder is 10 atmosphere. Now, let's assume I have just opened the valve. What will happen? Yes, come in. What will happen? What will happen if I open the cylinder of that cylinder? Whatever the hydrogen which is at 10 atmospheres will release out. So, what is the hydrogen now outside? Outside is 1 atmosphere. See, inside cylinder, I have maintained the pressure of hydrogen as 10 atmospheres. But once I release the valve here, hydrogen will be out of the cylinder. So, what is the pressure of the hydrogen at out? 1 atmosphere, because it's atmospheric pressure, where my atmosphere pressure is 1 atmosphere. So, that means what? Hydrogen at 10 atmospheres is coming out as hydrogen at 1 atmosphere. Are you getting here? A simple concept. I took a cylinder. I maintain hydrogen gas inside with 10 atmospheres. I just close it with some valve. Now outside atmosphere pressure is 1 atmosphere. Inside is 10 atmosphere. Now I just open the valve. So when I open it, hydrogen which is inside will go out. So hydrogen at 10 atmospheres will go out as hydrogen at 1 atmosphere. Now, if you remember the formula for Gibbs free energy in thermodynamics, delta G is equal to delta G naught plus RT ln P2 by P1. You remember? Fine. Now, standard Gibbs energy when they are in the elemental form, it is 0. So, delta G naught is 0. And keep the value of R, keep the value of temperature, because at room temperature, let us assume 25 degrees, or subsequently, if we convert into Kelvin, you convert it, and put ln P2 by P1. P2 is 1. And then P1 is 10. If you substitute, you got something around, you look at the value, minus 5.706 kilojoules. Now I have estimated delta G. For what delta G I have estimated? I have estimated delta G for this reaction. What is the reaction? Hydrogen at 10 atmospheres forming hydrogen at 1 atmosphere. So what is the delta G I obtained? What is the formula for delta G? Delta G is equal to delta G naught plus R ln P2 by P1, where P2 is 1, P1 is 10. I know R value, universal gas constant. I know the temperature, room temperature. If I substitute, I got around minus 5.706 kilojoule per mole. Now what is delta G with minus signature? Spontaneous reaction. That is why when I open the valve, quickly 10 atmospheres gas will release out at 1 atmosphere, which is at 1 atmosphere is the outside. It's a spontaneous. Quickly it will go out. Now look at the second figure. Instead of releasing into the atmosphere, what I did is I have connected with some small tube and I have put some plastic cover so that this gas can be collected here. Now on the small cover, plastic cover, I connected the tube and I put some weight here. Some weight on that. Now just open it. What will happen? In the first case, I just opened to atmosphere. But in the second case, I have connected with some small tube with some small plastic cover where the gas can be collected here. Now if you just open it, what will happen? Slowly the gas will be collected in the plastic bag. On top of it, what is there? Weight is there. So when I am releasing the valve, the gas is coming out. Slowly this plastic bag will expand, is it not? Because the gas is coming inside. So the bag initially like this, the gas will inserting into the bag so that it will rise. When it is rise means what? On top of that there is a weight. So that weight will be lifting up. That weight will be lifting up. Now come to the third case. The same 10 atmosphere cylinder, now what I did is, in front of the cylinder, I kept a sort of wheel-like structure, wherein for that wheel I have put some pulley. For that pulley I have hanged some weight. Understood now? Same cylinder at 10 atmospheres. Ahead I have kept some structure called some wheel like structure where it can rotate, and then I have a pulley connected to this wheel, and I have handed some weight. Now just open it. What will happen if I open it? So whatever the gas that is coming will try to rotate the wheel. So if it is rotated means what? This pulley will be moved. If the pulley will be moved means what? This weight will be lifted up. So some sort of weight lifting, some sort of energy I am getting, mechanical energy. Subsequently I can convert to some other form of energy. But in the first case, I have not used it. But I can use for lifting up, for converting to other forms. So this energy is called Gibbs free energy. The free energy is available here. I can extract, I can convert into other forms. So what is Gibbs free energy? The amount of energy that can be extracted from the system. The free energy available can be extracted from the system. You understood? So we never know that this hydrogen gas just simply leaving can be used for just lifting up, or can be used to some other forms of conversions. Is it not? I'm not supplying any external energy for lifting this weight or some other form of energy conversion. It is just a free energy available. 10 atmospheres is freely going out at 1 atmosphere. But that free energy I'm using for some weight, some potential energy, or some other forms of energy conversions. So the Gibbs free energy is the amount of energy that can be extractable from the system. That free energy is called Gibbs free energy. You understood now? From any system, you can extract some quantity of energy. That energy is called Gibbs free energy. So we never know that simply hydrogen at 10 atmospheres can be lifted up. If you intuitively think, the stored free energy is used to lifting up. So that free energy is called Gibbs free energy. Now just recollect what is chemical potential. What is chemical potential? That's what I'm saying. See, these are all very simple questions. If you understand the concept, it will be remembered for longer time. What is chemical potential? See, we have studied chemical potential. If I know, I studied in chemical potential in mass transfer because that subject starts with the definition of chemical potential. I have studied in thermodynamics. I have studied in reaction engineering. What is chemical potential then? Because I want that chemical potential here, because I want electrochemical potential in corrosion engineering. For that, if I know chemical potential, it's easy for me to understand electrochemical potential. Okay, like what I given an example here to understand Gibbs free energy. Let me give a small example so that you'll understand the chemical potential. See, just think of maybe some sort of, let's say, I have a small perfume bottle with me. Maybe small perfume bottle. It's not a perfume bottle, but remember, if I just open a perfume bottle, the moment I open, the smell is reached to the last guy. Why it has happened? If I just open the perfume bottle, the moment I open, quickly it reaches to the last person sitting very behind. So why it happened? Who asked these perfume molecules to go there? Who asked to go there? I have not asked him. I have not pushed. But why these perfume molecules have spread there, have diffused there? Wrong. Wrong. So more often the people will talk about only the concentration gradients. Wrong. It's the chemical potential. It's the chemical potential. It's the chemical potential of the species, molecules, that is driving them to go there because the energy is more. As I said, if for example, for the case of iron, what is the case of iron I told? Because it has come from the highest temperatures, it wants to lose the energy in order to become stable. Similarly, every molecule has its own chemical energy associated with her. It wants to release, it wants to free that energy in order to stable. So the molecules are tightly packed here. So if I release, they want to in stable state by traversing to the other place where the concentrations are less, where it can lose the energy to become stable. So the chemical potential is the chemical energy associated with that molecule, with that species, with that matter. That matter may be atoms, molecules, ions, electrons, whatever it may be the matter. You understood now what is the chemical potential? It's the chemical energy possessed by that molecule per number of moles. For example, I took some 5 number of moles. In 5 moles of that species, how much energy it possesses? Because of the energy, it is moving. It's not that the concentration moving. Of course, diffusion will take place always from the high concentration to low concentration. But the concentration gradient is not the one actual driving force. Actual driving force is the chemical potential. Because the potential is more for the species. It want to lessen it. Now, బుర్ర మీద weight ఎక్కువ ఉంటే నేను ఎప్పుడు unstable గా ఉంటాను. That is the case I explained you about the iron. Iron wants to be always in the lower energy state. Similarly, every species always wants to be in its minimum energy states. So when you are making the molecule to be in tight positions, it is always in under unstable state. So it always wants to be in stable state. So when it travels, it loses energy. Because of that smell, we are getting there. But it diffuses, it traverses, it transports to the place where it energy is lessened. Clear now? So that is the chemical potential. So whenever chemical potential is asked, it is the chemical energy associated with that molecule, with that species. More often we will call as molar Gibbs energy. If you remember. Okay. So maybe let us have a discussion of this derivation, but I don't want to discuss because derivation is not there. But I want the final term where I can use for the non-stick equation. So what is the final term? If you remember delta G in thermodynamics, delta G is equal to delta H minus T delta S, where delta S is entropy. What is entropy again? The maximum disorderness. So the entropy of the universe is, you might have written the gate exam. The entropy of the universe is always increasing. Why it will increase? Because of second law of thermodynamics. What is second law of thermodynamics? Gone. So these are fundamental questions. If you understand conceptually, logically, you will remember for longer time. Only thing is you have to connect to the different systems. See, I am connecting now the thermodynamics and mass transfer concepts to the corrosion principles. If you connect it, you will remember life for long. So okay. So delta G is equal to delta H minus T delta S. Delta H is equal to U plus PV. If you remember, what is U? So again, PdV. So TdS. So I can write work as minus PdV plus VdP. So with the terms neglected or cross-cut, I get delta G is almost equal to the electrical work. So I want to know that whatever the delta G which I have discussed in the previous slide is equal to the electrical work. Now what is electrical work? If you go back, electrical work is, maybe I can skip these things because this also you know. What is this? Delta G is equal to sigma mu Ni. This is what chemical potential definition I told you. Molar Gibbs energy. Chemical potential is equal to delta G by Ni. The chemical energy per mole is called chemical potential, which we call as delta G by Ni means molar Gibbs energy because that particular moles are involved in the Gibbs energy. So chemical potential, molar Gibbs energy are all equivalent terms. Gibbs energy and chemical potential ఒకటే డిఫరెంట్ కాదు. గుర్తుపెట్టుకోండి ఇవన్నీ కాన్సెప్ట్స్, క్లియర్ కాన్సెప్ట్స్. మోలార్ గిబ్స్ ఎనర్జీ అడిగినా కెమికల్ పొటెన్షియల్ అన్న కాన్సెప్ట్ సేమ్, ఈక్వల్ అది. సో మామూలుగా కాన్సెప్చువల్గా డెఫినేషన్ చెప్పాలంటే కెమికల్ ఎనర్జీ ఎంత ఉంది అది కెమికల్ పొటెన్షియల్. In terms of energies lo matladitte molar Gibbs energy antam because delta G by Ni. Okay, so let us look at what is W. Yes, the electrical work can be written as potential into charge. Electrical work can be written as potential into charge, and the charge can be written as N into F, where N is the number of electrons and F is the Faraday's constant. Now, if you substitute here N into F here, in place of Q, write substitute N into F, and potential is usually represented with EMFs, electromotive forces, so write with E. So, electrical work is equal to N into F into E. No, because delta G in the previous slide we have formulated as Gibbs energy is equal to the electrical work with the negative sign. I can write electrical work is equal to N of E, so minus N of E. So this is what the expression earlier I told. Delta G is equal to minus N of E. So in the electrochemical series, if you have E naught values, subsequently you know what is delta G values. Because how I obtain delta G values? You multiply the E values which are in the series with minus with N into F. So if E naught is positive means delta is negative. So that means what? Spontaneous reaction. So that reaction direction which has shown is a spontaneous reaction. So what is ultimately the equation for Gibbs free energy versus the potential? Delta G is equal to minus N into F into E naught, where E naught is the standard electrode potential, N is the number of electrons involved, F is the Faraday's constant, Gibbs free energy is delta G. Fine. So that is one expression. Now I should have, maybe you might know the activities and concentration. What is the difference between activity and concentration? When we use activity, when we use concentrations, what is activity coefficient? Thermodynamics. Look at here. This equation also you might know. G is equal to G naught plus RTL and A, where A is activity. I can write activity as in terms of products concentrations rise or the reactants concentrations rise. So if I substitute there, I'll get an equation like this. Because see delta G is equal to delta G naught plus RTL and Q, where because I already know delta G is minus N into F into E, delta G naught is minus N into F into E naught plus RTL and Q. And if I rearrange, if I divide this total equation with N into F, I will get E equal to E naught minus RT by NF into L and Q. This is my Nernst equation, wherein you see the relation. The potential is connected to the concentrations because Q means the coefficient, stoichiometric coefficient, that is the concentration or the activities in terms. So the activities are the concentrations connected to the potentials. So why you want this equation now? Because we have seen the potentials when I connected to normal heads in electrode. If I want to determine the standard electrode potential, what I did, I connected to the standard electrode potential SHE or NHE, because the E naught of NHE is 0. That is the reference I took. If you go back, so NHE, SHE, NHE or SHE, the E naught is 0. So I want to determine any electrode potential value E naught, I will connect with NHE so that the difference relative will be known. Now in doing such things, or if I do any electrochemical manipulations, like what when you have visited some plant, so there are some electrochemical reactions are going on, maybe the alkali production or the chlorine production. So where you react something, so when you react some moles of some reactant, definitely some charge will be out, some electricity will be coming out. So what could be my potential there? If I increase the concentrations, what could be my potential values? That is the relation. So the potentials is connected to the concentrations. How the activities or concentrations will influence the electrode potentials. Because that is very important. If you don't know the potential, you cannot control. See, for particular reactions, for example, I want chlorine. or I want something like I say alkali, sodium hydroxide. In order to produce sodium hydroxide, I need some reaction to be happen in the electrolyte solution. So that electrolyte solution, when I dip some electrodes, I have to operate only certain potentials. If that potential is crossed, you cannot accumulate or you cannot deposit the metal onto the surface. So what potential I have to operate? I have to know from the concentration. So this is the Nernst equation which talks about the relation between the potential versus the activities of the concentration. This equation is a little bit modified. Maybe I can talk to you about, yeah. Mn plus n electrons gives m. We know that equation. Standard oxidation reaction, So you know this expression. Now, because of this reaction, if I take this delta G naught plus RT ln Q, Q is the quotient of the products. That is activity of the product m by activity of the Mn plus. So if I just substitute the activities, maybe I'll get like this. Yeah. ln m by mn plus, okay, because I know delta G is minus NFE, divided the same Nernst equation can be converted into a standard form. Yes, this is the form, or this is the form. It's just expressions where I can substitute log values or substitute R and T values. If I substitute R value, universal gas constant, temperature value, I'll get this expression. See, standard 298, 25 degrees centigrade, 298. If I substitute R value, in this I'll get this expression. So more frequently either use this expression or this expression, which are called Nernst equation. Okay, fine. So what is the significance of Nernst equation? You go back here. I have written significance. See? The Nernst equation tells us that a half cell potential will change by 59 millivolts per tenfold change in the concentration of a substance involved in a one electron oxidation or reduction process. See, tenfold change. So the reaction rates are changing by tenfold. When when just 59 millivolts potential is involved. So the potential is changing with the concentration. That is the significance of Nernst equation. So if you do one or two problems, that will be good. But this course does not have the problems. So I'm not dealing that way. Just significance I'm saying. The Nernst equation, what is the equation? You just remember E equal to E naught plus 2.803 by RT into N of into ln of something concentrations or the activities. You just remember the equation, that's enough. What is the significance? You write it. Okay? If you want, you can solve the problems which are there in the formula textbook. You can solve it. Okay? Yeah, maybe the next concepts are little bit trivial, which takes some more understanding of the phase diagrams, the thermodynamics. So I'll take maybe in a separate class because that needs more elaborate phase concepts. Maybe I can show you some of the things so you will come across. That, yeah, maybe you know this. Uh, because just now we have come across delta G is equal to minus N into F into E. We already know from the thermodynamics delta G is equal to minus RT ln K. Remember what is K? Equilibrium constant. K is equilibrium constant. Now we already understand the equation of Nernst. Now E equal to E naught plus RT by N of this equation we understood. Now see, these are all interconnected terms. If you remember delta G and then what is E and then what is equilibrium constant K. It's a independent dependent terms. If you just know delta G and E, you can calculate K. Or if you know K and delta G, you can calculate E. Now, the significance is also very simple. If you know delta G, the E can be known because delta G is equal to minus NFE. If you know delta G, the K can be known because delta G is equal to minus RT ln K. So if you know K, positive or negative, you can talk about the reaction. because the equilibrium constant is 1 or less than 1 or greater than 1. Similarly, if you know delta G, negative or 0 or positive, you know the reaction. Spontaneous or non-spontaneous or equilibrium. Okay? Yeah, maybe I can stop here because there is one question I have asked for your seniors. Maybe I can discuss that question. Based on the delta G, I have framed one question. Uh, Maybe I can remember only one girl has answered. That girl is Sri Lankan girl, Jayavardhane something. I couldn't remember her name. Avishka something. Kanishka, yes, Kanishka. She only answered that question. Among all 66 candidates in that batch, she only answered that question correctly. Okay, so what is the question I have given is, so for you also I'm just reading. So after understanding the delta G naught, after understanding the equilibrium constant K, after understanding the entropy, I have given some four equations. I have given some four chemical equations, and I asked for every reaction feasible or not. Okay, maybe I couldn't remember the what are the four reactions given, but I can give you now. Let us take one example. N2 plus 3H2 gives rise to NH3. N2, note it down. N2 plus 3H2 gives rise to NH3. What is the state of N2? Gas. State of H2? Gas. State of ammonia? State of ammonia? Ammonia. Solid or gas? Ammonia, liquid. Ammonium hydroxide is a aqueous solution. Whereas ammonia can be in liquid state, can be in gaseous state. So for time being, let us write ammonia in the liquid state. That means ammonia existing in the form of ammonium hydroxide. Let us assume from that ammonia can be produced. But you write just NH3 as L in the suffix. Now for this reaction, I asked whether this reaction is feasible or not. I have not given any hints. Like this equation, I have given some 5 or 6 equations. For each equation, 1 mark I have given, and only that girl has answered. No one has answered. How do you answer that question? I explained the concept of Gibbs energy, I explained the entropy, I explained equilibrium constant. So if you know the exactly the definition of entropy, you can solve that question. What is entropy? The maximum disorderness or randomness of a system is called entropy. Right? Now, in which case the entropy will be more liquid, solids, or gases? Gases, because gas molecules are spread throughout. So, maximum disorderness or randomness will be there. So, gases has more entropy values compared to liquid, and the liquids are more entropy values compared to solid. Because solids, the atoms or molecules are regularly arranged, crystalline. We know. So liquids has more entropy than solids, and gases has more entropy than liquids and solids. Now what about the total reactants entropy value now? Here in this reaction, both are gases. So the entropy is more on the left side. Now what is the product I told? Liquids. So liquids has lesser entropy than gases. So in our total reaction, the entropy is going to decrease or increase. So from higher entropy values, because the left side is gases, the products are getting lesser values. So the entropy is getting down. So entropy is getting down means what could be the energies? Energies will increase. If you remember thermodynamics, entropy decrease, energy will increase. If energy increase gives me energy, that is what the connection I have asked you to think. And she only did correctly. In fact, I'm surprised. Maybe one mistake she has no. She has done correctly all the equations I have given. So that's what, and why I'm quoting this is, in fact, she is not from our country. She is from other country, and I don't know. See, other country people are coming here, and say they will struggle because more often the teachers in our countries will speak in language called Telugu, and she might have struggled a lot to understand the basics because more often the teachers will handle the classes in local languages. And she is, in fact, I don't know how she has murmured the subject. She did correctly all the equations I have given. She understood perfectly the concept and executed. That is what the fundamental knowledge. More often, people will look at the concept-oriented minds rather than what we call gold medal, 9 CGPA, 9.5. Who want 9.5 CGPA? Who want your gold medals? People will want the skill sets, the technical or sound knowledge, core competency. Fine. You might have seen yesterday's exam pattern there. I don't know how. So they are, even if your program is correct, they are coming, interfering you, asking the logic, asking if this line has been replaced with other thing. What could be the output? Have you seen yesterday's the mode of exam pattern? The package is more, so they look at you in different aspects. Just getting the code, whatever they asked, if you execute it, you won't get the job. They'll interfere you. Yesterday it was happened. They are asking in between, and you change this line, put another line. How could be your output? So ultimately, only six people have scrutinized in yesterday's exam. Only six people. And today there is another exam, and today there will be another pattern where those can be scrutinized again. Ultimately, one or two people they will take because they are offering good package. Why I will give good package? Until and unless I very am confident about your skill sets. Good. So we need to improvise our technical skills, sound knowledge of the core competency. Okay. So let me stop here so that I can start afresh the what we call the phase diagrams, and more importantly, their